Alright, so let's see if this recording actually captures my voice. Alright, so this is my Unity presentation of what I have so far. Let's jump into the code. So we have this script to enable the player sphere to move based on their speed, drag, turn, rotation, and the rigid body that they have, which is found in the player sphere. That is not the player sphere. This is the player sphere, with their rigid body over here. I wasn't really too sure what the true difference between force and torque in Unity was, so I just left this alone for now. So we grab the rigid body from the sphere. We assign it its angular velocity based on the terminal rotation and the drag from the drag, the inputs that we have here. Fixed update is really important such that the physics calculations are calculated before every frame is processed. That way things look a lot better when things are moving around rather than just simply update. Since the ball is moving through the X direction and the Z direction, Y being up and down, we grab those inputs from the joystick, which I'll explain later on. This is very key because since we want the ball to move according to what the camera is looking at, this helps based on the camera's forward, or the forward vector of the camera, so that whatever you look at, the ball will also roll up in the same direction, which I'll show, which probably might be better later on. And we just grab the direction of the ball based on all this and normalize it if it's over the 1, and we add that force based on the speed value that we have here, speed of 5. The joysticks, which a lot of inheritance, being able to use their interfaces in relation to the how these joysticks kind of touch with the mouse. So on drag, this is an interface where if the user is kind of like dragging this joystick around, we want to define like where are they allowed to touch to in order to activate this, and where and how far they're able to move the circle around. And we get a position of an X and Y axis from this 2D joystick sprite, so we can translate it in relation to the ball movements in the 3D plane. As defined here from the input direction. Now, should the user let go of the joystick, we want to set it so that it resetts back to its original position with vector 3 of 0. The joystick is also a child of this canvas image right here, so that's affected right here. We also have movement camera, mainly so that we could like define like the distance away, the faces away from the player, how sensitive the camera movements can be, and most importantly, the placing restriction on the player on how much control they have over the camera, such that they won't go over 90 degrees, they won't go 89.9 degrees, or they won't go below the 0th degree, in which the camera clips into the floor and you can see everything as the camera dips into the floor, which we want to prevent. I'm going to have layup here to calculate the physics before each frame is processed. Alright, so now we can get into the main part of the video. So let's start off with Server Manager. The Server Manager essentially initializes, and if we were to change scenes, which I'm yet to implement properly, then we don't destroy this object. Else then we try to gracefully close our sockets. So here's what the server looks like. After copying all of this from my testing of a server in C# to actually be able to be used in Unity. It wasn't too much of a big change, thankfully. So, yes. So we listened for our socket server, in which that it's binded through its IP address. Each connection that we get is stored in our list of clients, which is super useful in keeping track of where we receive data, and more importantly, where we send data to. We also give this server socket its own thread. Listen up to 10 connections as well. So this I will get to in a later bit once I explain getting client data, in which we record their socket, thread, ID, and their IP address and port as well. Should I somehow forgot to add any important data whatsoever, I throw an exception. Else, we record all the necessary information and give their own thread, in which then we send a registration packet, which is like, hey, what's your ID, to the client. This is kind of a work in progress. I also thought about different ways to dispose sockets in case one disconnects. But I seem to have it handled when I explain what get data does. Alright, so since we're using a thread, we want to pass in an object that we can typecast back into a client socket. We have our buffer of the array of bytes to received, and our integer bytes, of which how many bytes we actually read from the data, as well as where to store it once we actually read the data. So once we assign this byte the size, we receive all of our data from the we receive all of our data into a read bytes format, in which case we can read up to how many bytes there is to be actually used. If not, then we just shut down this client. So we also assign data to be the size of the read bytes, and we just copy over whatever is in the buffer to the data. And then we send out a new packet full of this nice data that we're going to send out to each of the other clients. And we handle that data based on the packet and what client this is. This is more so to help gracefully close a client in case they get an exit type packet. So we gracefully close a socket. So as we handle data, the packets are of different types. So if we have the send packet that we're sending to the clients, then we're going to send each of them the packet as bytes. And we have catch exceptions in case something were to go wrong, like a client disconnecting unexpectedly. And if they were to gracefully exit, then all we do is just send up an exit acknowledging that, okay, we're gonna allow you to exit. And this helps the server gracefully shut down as well. I believe I talked about everything inside here. Handle data, get data, sock thread, yes. Okay, so let's talk about the packets. So we want all the packets to be able to convert to and from bytes. We have our packet types, where register helps to ID a client. Send actually sends like all the messages between to and from clients. Heartbeat is actually pretty useful just to help identify if a client is still connected or not, else then we just close our socket. Info is to test the packet types in the chat box, which I'll explain to you later. And the exit is to help gracefully disconnect the socket. So once we initialize our packets, we want to have a data new list of strings readily available to be used, along with what the ID of the sender is and the type of packet that we use. I was thinking of also using booleans and integers, which might become useful as I develop the game, so I just left it there for now. Probably such as updating player movement or some value or whatnot. If an object is destroyed, true or false or whatever. But anyway, we want to convert these packets to bytes. Actually, let me talk more in depth about this. So we initialize a packet. We just of type and string. We just want to create a list. But if we're initializing a packet from bytes, we want to deserialize them, meaning we want to convert the bytes into an actual packet, as seen here, and do what we want with this packet. Now we're turning them into bytes. Then we simply use this binary formatter to serialize the memory stream, which is the information that we're using in case this, where this is entering the memory stream and becoming bytes. Then we return the bytes so it can be sent via sockets. Now this is also pretty useful. We want to get the IP address of the server that's hosting. If not, then we just give it a local host. Server client. Ah, yes. So the last piece of code right here is the client, where these messages help us in pushing messages to the chat box. This right here. Alright, so we create our instance variables to keep track of a lot of information, such as the chat messages, the message limit, our client socket, their ID, the chat panels that are right here, text objects in the chat box, as well as the colors of what the text would be depending on the different packet types. So we assign an ID to the clients, which GUID gives them a completely random ID that I believe is sure to be always different, like in the sense that no two IDs will be the same. At least I hope. Alright. Functionality to type in any IP we'll allow for later. And the IP would be this, what the server is bound to. So then we connect via TCP, giving an endpoint of the IP and our port number, which the port number of the server is also the same, I believe. Server manager. We bind it to 1 2 3 4 5. Alright, just to be sure. If not, we let the user give them at least 3 seconds to read the message before we disconnect. And we start off a new thread on our client and start it. Yay. Now normally, on a console, we will just execute while this right here to loop forever, in which case we keep sending keep sending the packets from the client socket. But we don't want to do that in Unity because we have this lovely update method right here that can help us process that with the chat box. Field is empty, let's send messages. Displaying the message and sending it to other players. Else, then we help to process the messages that will be sent. And this right here is to help test out how well the messages act. In which case, when we do send messages to other players, in case the messages are over the limit, we want to destroy them and remove them from the list of messages that we have. Else, we create a packet. Actually, no, not else, but furthermore, we create a packet of a sending type along with their ID to be sent to the rest of the clients as bytes. Server messages works exactly like the same thing, except that we get messages from the server this time from other clients, such that we can now push whatever messages we get onto our chat box. Let's get ID. Getting the data works almost essentially the same. We have a byte or buffer, we have our read bytes. We have our read bytes depending on how much we receive from the client, and we store our buffer. This should be read bytes, but I will fix that later on. In the meantime, we handle the data that we got. This helps to adjust the colors of the messages. And then depending on the type of packet that we get, we just handle what happens, such as pushing messages to the chat box, checking if the socket's still alive. And here, I just want to really make sure that we gracefully disconnect. Anyway, enough about code. Let's see how this works. So let me rebuild this as build number 7. I misspelled that, but you know what? That's okay. Actually, you know what? I could still rename this. Okay, so moving ball, which is this scene, is gonna play when I execute the executable, but I need the server to be running first. So I'm gonna switch scenes as soon as this building process finishes. Network manager. Also the different properties of these components. Content, text, and input field. Canvas with our joysticks, our scroll view, our input view field as well here. So let's switch to network manager, which is just the server. So we initialize our server. Let's go to executable. This. Put 1.exe. Let's create 3 instances of this. Yep, we got 3 instances. So we can enter text. Hey, this is 1. How are you guys? I should really fix this small text. And it's received by the other client, so that's pretty awesome. And it's received by the server as well. Hey, oh, wrong one. Hey, this is to such joy 443. And I can rotate this camera, move up with the ball in relation to the camera. Even though I'm moving back, I'm still moving up in relation to the camera. So if I go left, I go right in relation to the camera. Now I plan for when I have player movement, which is what I want to work on next, is that on Unity Update, I'm going to send player movement over the socket so that the recorded information on the player list that each client will have will always continuously change values, which is my plan so far. So, thank you for watching, and hopefully this will be completed later on. Yeah! Oh, I know this will be completed later on, but I just hope with good luck and goodwill that there will be. too many problems down the road, hopefully. Alright, yeah.